Swayam Prabha. Digital India. Educated India.
Hello, welcome to this MOOC on basics of noise and its measurement. Today is our first day of the lectures in a series of lectures. This particular course is going to run for an 8-week period. Each week we will have 6 modules. Each module will be something about 18, 20, 25 minutes long, and in each of these weeks, we will cover a very large, or not necessarily very large, but a comprehensive suite of topics which relate to this particular MOOC. As you see, this the title is Basics of Noise and its Measurement. And before we start digging deep into the details of this course, just wanted to share my understanding of why is measurement of noise important. Well, as it turns out that noise is becoming increasingly a very important parameter in terms of our lifestyle, influencing our lifestyle. You get up in the morning, you go out, you are on the road, you hear a lot of noise. You go to your kitchen and you use a mixie or a fruit processor, it generates noise. You have a refrigerator, there could be a less noisy refrigerator, a more noisy refrigerator. You have a washing machine, it generates noise. You have aircraft, ships, rockets, and whatever. You have a lot of noise, and in general, the overall level of noise in our country is going up very significantly. So if you are involved in manufacture and design and production of consumer goods, you would like your consumer goods to be less noisy, because that makes them competitively better. If you are involved in design of and running of complex transportation systems such as aircrafts or railways, again from the standpoint of from the side of the government as well from the standpoint of the users of this, there is an increasing desire to reduce the noise levels which are generated by trucks, by buses, by cars, by trains, by planes, and so on and so forth. So what this course does is that it looks at this overall comprehensive picture, and as a step one, it gives you a fundamental understanding of what is sound. So we will cover a range of very basic themes related to sound, and then we will proceed in terms of how do we measure sound, how do we measure noise, and how to analyze the signals which we have measured. So before we start going into the details, I would like to share some of the resources in this particular context. These particular resources may turn out to be very helpful for you as you dig deeper into this particular area. So in this particular context, you may also want to look at some of the video courses and web-based courses on acoustics and sound propagation through media, which are being offered by NPTEL. So you have to go to nptel.ac.in and look for these courses, and I have developed 40 video courses and another 40 web-based lectures on sound propagation through media. And if you have the time to go through them and learn a little bit more about acoustics and sound propagation, it will be really helpful for you in context of this course. But as a prerequisite, you do not have to necessarily learn all those things which I've taught in acoustics and sound propagation through media to be a part of this course. But if you learn that, then it will certainly be helpful. Then, of course, I'm doing this MOOC on acoustics, so we will generate a lot of supplementary material. But then there is also a virtual lab on acoustics, and we at IIT Kanpur, we have created this laboratory, and this is the URL for the lab. It's not a very imaginative URL, but right now this is what we have. Hopefully in next few weeks we will be able to change the URL to something more meaningful. But if you go to this particular website, http://202.3.77.82, you will be able to access a large number of acoustics tools, software tools, using which you can generate a lot of files. If you want to create a 400 hertz tone, you can generate that. If you want to generate a sweep signal, a hash signal, and so on and so forth, you should be able to do that. If you have a particular signal and if you want to do FFT of it, you should be able to do that at this website. So this, feel free to use it. There's no charge for it. And the more people use it, the better it will be in terms of utilization of this resource. And then finally we have Dhwani Labs, which is again labs where we do a lot of research in area of sound and acoustics and noise. And this is the URL for that. So if you go here, you will learn something more about what kind of resources we have in terms of people, in terms of equipment, in terms of other tools. And you should be able to capitalize on these resources. And if you have any questions and if you have research interest in this particular area of noise and vibrations, it grows, then you're welcome to use all these facilities. So now let's look at the structure of our course. So we will have a series of lectures, or brief lectures if you may, and each lecture will be something like 20-25 minutes, and this will be supplemented by some additional material. So with each lecture we will also have a series of presentations, PowerPoint presentations, so you are free to look at those. And at the end of each assignment, each lecture, we will have an assignment, and by and large most of the assignments which you will have to finish would be multiple choice format. So there will be objective questions of MCQ type. So if you have understood the concept, then you should be able to answer them, these questions in a MCQ format. I'm certain that as we proceed into the course, you will have doubts and questions and need for clarification of specific concepts. So there will be tutors, and of course I'll be available for online interaction. So you should be able to pass on your questions and interact with the tutors and also me through this online interaction methodology. And as the course draws to a close, there will be a final examination, and that will help us evaluate the performance of all of you on this course. So that is going to be the overall structure of this course, and I look forward to having you on this particular course. Now let's look at briefly about what is it that we are going to discuss in this particular course. So of course there's going to be an introductory part, and after that what we will do is that we will look at some of the key terminologies, because a lot of terminology of noise and acoustics is somewhat specific, like we have terms like octaves and decades and decibels and LEQ and power intensity, and it's important that we understand these terms accurately: band, bandwidth, what else, weighting, A weighting, filters. So it's important that you understand this terminology clearly and explicitly, and that will help you discuss about acoustics and noise related measurements with your peers in a very clear and objective way. Once we have discussed the terminology, then we will proceed to look at the very fundamental mechanics of sound. How does sound propagate from point A to point B? And that is governed by a differential equation known as the wave equation. So understanding the basics of this wave equation is important in this course, because not necessarily in the sense that you have to be super experts in solving these differential equations, but rather because a lot of times if you understand what the wave equation is, then you would be able to relate the underlying mechanics associated with this wave equation with several principles of noise measurement, because there are things like impedance, and the concept of impedance comes directly out of the wave equation, because we take the ratios of pressure and velocity, and then as a function of the pressure and velocity we define something known as impedance. So how are these things related? And how do they relate to some of these terms which we will be measuring? It's important that we understand the wave equation. So once we are done with understanding the wave equation, we'll use it, we'll cover this wave equation over a period of 2 or at the most 3 hours. Then we will actually proceed to actually measuring sound. So in that particular context, we will look at a large range of equipments, microphones, data acquisition systems, analog to digital converters, what types of cables do we use, sound level meters, and so on and so forth. And we will look at all these from a practical standpoint, and in this lab we'll also actually show you some of these specific instruments and tools and familiarize you with the basic operating principles as well as specifications of these tools, so that once you walk out of this MOOC after having successfully completed this course, you should be able to intelligently figure out what kind of measurements do you have to do and what kind of instruments will be helpful in achieving your goals. So once that is done, then what? So once you have a tool and you use this tool to record sound or noise, if you may, then you have to analyze all that information. And because most of the information you record is it is in time domain. You basically measure pressure as a function of time, or velocity or volume velocity as a function of time, and once you record that, then you would like to extract a lot of other information which may be of interest. You may be interested in trying to figure out what is the energy level in a particular bandwidth, or what is the sound pressure level at a particular frequency. So what is needed at that stage is that you should have reasonable grounding in analyzing all the data which you have acquired experimentally, and all that analysis is done through some mathematical methods, and those are the mathematical methods which we will discuss in this particular course. Specifically, we will cover FFT or fast Fourier transform method, and how can we make FFT more accurate, what is the resolution of an FFT, what is the maximum frequency which we can get once we FFT some data, and so on and so forth. Then we will also look at another tool known as the spectrogram, and also the short term fast Fourier transform method. And once we are done with it, then we will learn a little bit more about how we can use these tools and these techniques for different applications. And we will discuss some of these technical terms later, which are shown on this particular PowerPoint. So how can we apply these tools and techniques to free field measurements, to reverberant field measurements, to near field measurements? How is the near field measurement different fundamentally from a far field measurement? And what is the use of something known as anechoic chamber? We'll discuss that. What is weighting? What are octave bands? And so on and so forth. So once we are done with this, then we will continue our journey in the area of noise measurements. And then we will learn to define and measure experimentally a very important parameter, or a parameter, which is a function of pressure and velocity, and this is known as impedance. And we will discuss at least two different methods to measure impedance. We will also describe the equipment which is used to measure impedance, and actually give a demonstration of one of those equipments for impedance measurement. And then we will show that how we can use this equipment to measure the noise absorption characteristics of different materials. For instance, you have a foam or a piece of cork which you want that it should be able to absorb sound in an auditorium which you are designing. So you would like to know that for specific frequency bandwidth, let's say 100 to 200 hertz, 200 to 400 hertz, 400 to 800 hertz, and so on and so forth, how much noise this particular piece of foam or cork or felt or concrete or curtain it absorbs. And what we will teach you is how you can actually do these measurements using these impedance related tools. Because then once you know how to do this, then you can calculate the absorption coefficients of these materials, and through some quick mathematical models actually design auditoriums which sound better. So it will be in that sense fairly effective tool for you all. And then once we have done that, then you will be ready at that point of time to discuss and learn how are measurements made for designing better public places. So in public places, what you want is that there shouldn't be necessarily too long a reverberation time, because that confuses people, and also it shouldn't be too short. So there is always an optimum level of reverberation time. And how do you design public places from an acoustical standpoint? How do you design a classroom, a lecture hall, an auditorium? So some very basics of that by relying on some of the measurement techniques which you have, which you would be learning in this particular course. And then finally, we will look at some of the national as well as international standards as they relate to sound and noise, and what kind of levels are permissible in specific areas, what kind of sound level or noise level is permissible in a public area, in a hospital, in an airport, inside a car, or when a car goes by, there's something known as a pass-by noise. So what kind of standards do we have, and regulatory standards as well as operational standards which are important to look at as you execute your responsibilities as a noise engineer or as a sound engineer or as an operations manager in your organization. So that is something we will be covering in this course. And lastly, so once again, I look forward to having you in this course, and I'm sure that this will be a fun journey, and it will be highly interactive, and I don't think it will be consuming an excessively large amount of time from your standpoint in terms of learning, but I'm fairly certain that you will find this course to be rewarding, enriching, and something you will be learning which will be very useful and rewarding from a practical standpoint. So welcome to the course, And this completes the first module of this course. And now we will proceed to the second module.